proceedings of the event. We now await the arrival of the chief guest. Ladies and gentlemen, we welcome Lieutenant General Daljit Singh, Ati Vishish Seva Medal, President's Honorary Surgeon, the Director General Armed Forces Medical Services, and Senior Colonel Commandant Army Medical Corps.
As part of our celebrations, we have the honor of hosting a distinguished speaker who will deliver the Platinum Jubilee Oration, which marks a significant milestone in our journey of excellence. The chairperson for this session is Lieutenant General Arindam Chatterjee, Ati Vishish Seva Medal, Director General Medical Services Army. May I please request, sir, to kindly take his chair on stage. With an illustrious military career spanning over 3 decades, Lieutenant General Arindam Chatterjee is an administrator and academician par excellence. He has been bestowed with an array of military decorations, including the Ati Vishesh Seva Medal and Vishesh Seva Medal. The General Officer has held several important staff appointments, including Director General Organization and Personnel AFMS, Office of DG AFMS, Director General Medical Services Navy, and is at present the Director General Medical Services Army.
The co-chairperson for this session is Air Marshal Rajesh Vaidya, Vishisht Seva Medal, Director General Medical Services Air. May I now request Sir to take his chair on the stage. Air Marshal Rajesh Vaidya is a community medicine specialist who has been the contributing author and editor for many important publications of repute. The Air Marshal has held the prestigious appointment of Dean and Deputy Commandant, Armed Forces Medical College, Pune. He has been conferred with the prestigious Vishisht Seva Medal and Chief of Air Staff Commendation for his meritorious contributions to the organization. May I now request the chairpersons to kindly take over the proceedings of the session.
Thank you. A very good morning to all of you. It's a privilege to be here amongst this very august gathering of very eminent alumni and all the delegates. Of course, it's also a privilege which I must thank the Commandant AFMC for and his team for inviting me to be one of the co-chairs for this session in which a very eminent alumni is going to speak about the subject matter. Can I have the slide, please? The subject matter being innovating for global kidney care, patients, policy, and precision medicine. This has 3 elements to it. And I think the eminent speaker has a very large canvas that he wants to talk about. When he talks about patients, obviously there's a whole lot of clinical relationship which is equipped with this subject. He talks about policy, which means the entire gamut of policy making, policy implementation, the challenges to the policy. And lastly, the precision medicine, which I presume is where he's going to take us as the frontiers of new medicine. Dr. Prabir Roy Chaudhary, the eminent speaker for today, is an alumni of AFMC. We are very proud to have him here amongst us, batch of 1979, and what we call the R batch. Graduated from AFMC, and then shortly thereafter moved abroad. He's earned a whole lot of credentials to himself, an MD, then he's done his PhD, thereafter his specialization further in nephrology. He's got his FRCP from Edinburgh. Actually, I shouldn't be reading this out. I'm just going to give you 30 seconds. Please read his biodata. Very briefly, he holds the professor in the Drs. Ronald and Catherine Falk Eminent Professorship and co-director of the University of North Carolina Kidney Center. The staff nephrologist at the Salisbury Veterans Administration Medical Center. Did his medicine nephrology from University of Aberdeen, Scotland, and from the Harvard Medical School, Boston. His current research interest for some time now has been in uremic vascular biology. He's also a prolific academician, a researcher, a clinician, and now, of course, into policy making. Recipient of an extensive number of research grants from some of the largest agencies in US, namely the National Institutes of Health, and the VA administration. A very sought-after speaker, Dr. Roy Chaudhary, has been the past president of the American Nephrologists of Indian origin. He's a founding American Society of Nephrologists co-chair of the Kidney Health Initiative, which is a public-private partnership between American Society of Nephrologists and the US FDA. He's also a member of the steering committee for the Kidney X Innovation Accelerator, which is again a public-private partnership between the American Society of Nephrologists and the US Department of Health and Human Services. Currently, the secretary of the American Society of Nephrology. He's also the president designate of the same society, one of the largest societies in the US with about 19,000 members. Friends, I'm not going to take up time what is rightfully his. His academic profile is amazing. Were I to spend more time on it, I'd only eat into his time. May I request Dr. Prabir Roy Chaudhary to kindly join us? And as you will get to understand the complexity and the scope of what he's going to talk about, may I now request Dr. Roy Chaudhary to kindly take it away, please. Thank you, sir.
All right. Well, I just want to say that I am truly honored and privileged to be here. It is a very, very special honor for me. I thank you for the very kind introduction. And I'm going to start off actually with a little bit of a journey down memory lane. I'm an R batch graduate. I first came to AFMC on the 20th of July, 1979, together with some of my fellow R batches in the audience, including the Director General. This is a picture of me taken later on in front of the 6th floor hostel. I was AFG 2185. I had a lot of hair in those days. That's me down here. That's Prashant Bharadwaj, who just retired as DGMS Air. And I was able to pull out this next picture, which also has your Director General. And here is General Daljit Singh. He was always very distinguished. You can see him even now, sort of staying up erect, where all the rest of us are sort of slouched around. I also want to recognize the person standing next to Daljit. PC Alexander was a dear friend of mine who passed away after a liver transplant operation some years ago. These are my disclosures. And what I'm going to do in the next 40 minutes I timed it for is, first of all, to define the different types of innovation and then describe to you the current burden of kidney disease worldwide. I'm then going to use this information to make a case for patient-centered innovation in kidney care, and then I'm going to give you some examples of kidney innovation. And these two parts of the presentation obviously can be applied to any field in medicine. So I'm using kidney care here as an example, and all of you in different specialties should be free to think about how it applies to your specialty. And then I'm going to end with a message for the future. A little bit about innovation. The definition on the left really describes it as a new method, idea, or device, the introduction of something new. I think that the business definition, which is the practice of developing and marketing breakthrough products and services, in a way is closer to the truth. The way that I think about innovation is in the context of the who, the what, and the how. So the who, you have to have a who if you want to do innovation, right? And the who is a customer, in our case, patients with a need or a gap. In my case specifically, kidney patients. The what is all about discovery innovations or about creating the solution. So in the context of kidney care, it's about the ideas and solutions that improve the lives of kidney patients. And then the how of innovation is something we often forget about. It's process innovation, or the way that the discovery gets to the customer, the patient, other physicians. In my world, it's the implementation pathways to get new discoveries to the kidney patients who do so desperately need them. And that applies again, obviously, to patients in other specialties. This slide just gives you the fun part about innovation and some messages. So you have to think out of the box for innovation. So Thomas Edison didn't set out to develop a better candle when he developed the light bulb. And Henry Ford didn't want to just build a better horse-drawn carriage. What's often forgotten is that Edison's greatest achievement was maybe not creating the light bulb, but the process to manufacture light bulbs in bulk. And similarly for Henry Ford, it was the implementation, the process innovation of the assembly line that allowed cars to become so common. And if you look at the pictures on the right, this is a street in New York in 1903. There's only one automobile, the rest are all horse-drawn carriages. 10 years later, there isn't a horse in sight. And, you know, in our world, we are living in the midst of this, and Uber and cell phones are just two things that immediately come to mind. So now I'm going to shift to kidney care. I started off by saying that I had a message for the future at the end, but I have a message for the present. And the message for the present in the context of kidney care is that we really have a crisis in kidney care at the present time. The American Society of Nephrology, together with the International Society of Nephrology and the European Renal Association, have determined, and this is a rough estimate, that there are 850 million people worldwide who have kidney disease. The number of patients with kidney disease across the breadth of chronic kidney disease to dialysis in India is estimated to be about 120 million, which is actually probably an undercount. Kidney care costs a huge amount of money. In the United States, it's 1 in 5 Medicare dollars. I looked hard to find out a total amount in India, and obviously that varies because of the private world and the government world, but it was difficult to find out. But the biggest message is that even though so much money and effort is spent on kidney care, the results are really very poor. So in the United States, if you start onto dialysis, 100 patients start onto dialysis, 50 of them would be dead after 3 years. 12 patients die daily waiting for a transplant in the US, and obviously kidney transplants don't last forever. But what I do want to emphasize is that these are actually, if I can get my arrow, these are the lucky people on the right, because the harsh reality is that even though we dialyzed 3 million people in 2020, there were at least another 8 million people who died because of the lack of kidney replacement therapy. And pretty much all of those people were in the countries shown in blue on this map, where light blue indicates a poorer or a lower access or accessibility of dialysis. And of course, most of the people on this planet live in the light blue countries. I'm going to go back to the 3 million people that did get dialysis, let's say, to sort of make the point about innovation. But again, the principles can be applied across all specialties. I would argue very strongly that at the present time, we provide very poor value in end-stage kidney disease care through dialysis. And the reason I say this is that we have bad outcomes. We spoke about the 50% 3-year survival. But in order to achieve these relatively bad outcomes, we actually spend a huge amount of money. And if you look at the right panel, you'll see that the 5-year survival on hemodialysis, and this is obviously only if you have access to hemodialysis, is actually worse than pretty much every form of cancer, except potentially things like pancreatic or lung cancer. So why is this the case? And I would argue that one of the main reasons for the poor survival on dialysis in this case, using it as an example, is that there's been relatively little change in dialysis technology over the last 50 years. So if you look at the panel on the left, you see somebody on dialysis at the Royal Free Hospital in London in 1965. Fast forward 50 years, the basic construct is essentially the same. Yes, there are some bells and whistles for the person on the right, but the basic construct has not changed. Now, I want you to keep this picture in your mind's eye while I go to the next one, which is the change that has happened in 50 years in another technology-rich area of life, which is computing. And I can guarantee you that any of the little devices that all of you are holding or have in your hand, and I'm delighted that none of you are looking at your cell phones, but any one of them has more computing power than the huge IBM computer on the left. So the question that I want to address in the context of innovation is, so how do we break the cycle that starts off with a lack of innovation, results in poor quality and outcomes, and a high cost burden, and then repeats itself? And I am going to submit to all of you that one way that we can break the cycle is through patient-centered innovation. So what is patient-centered innovation? It's basically innovation, and it could be the discovery innovation or the process of care innovation that we spoke about, that targets the issues that are important to the patient, not necessarily what is important to physicians or payers or regulators or industry partners. And the reason that this is so important is that the things that are important to patients are often very different from the things that are important to, let's say, physicians. And this is just an example from the dialysis world, where you can see that if you speak to patients on hemodialysis, they're worried about ability to travel and dialysis, free time, not feeling washed out after dialysis is a huge thing. But if you speak to the physicians who are caring for those same patients, we basically talk about survival. And as nephrologists, of course, we talk about blood pressure, too high, too low, just right. So very, very different. The next question, of course, is, well, how do we develop therapies that address the issues that patients feel are important? And the way to do that, of course, is to get input from patients at every point in the product development process, which is shown on this slide through a friend at the FDA, which goes all the way from initial ideation to patient-informed clinical trial design, to patient preferences, and then finally to patient-reported outcomes that are now being used more and more as endpoints for clinical trial. But my just standing here and saying that this is important doesn't make it so. And one of the ways that we have really tried to bring the patient perspective into kidney innovation is through the Kidney Health Initiative. And as was referred to earlier, and thank you again for that very nice introduction, the Kidney Health Initiative is a public-private partnership between the FDA and the ASN. It was formed in September of 2012, so 10 years now. I was privileged to be the founding co-director of the Kidney Health Initiative. We have over 100 members, which include industry partners and patient organizations, health professional organizations, and federal agencies. And again, a big part of this is really coming together. And the goal was to create an innovation substrate to facilitate the passage of new therapies into the kidney space by doing innovative projects. So very much around process innovation. What we really wanted to do more than anything else, and this is probably the most important thing I'm going to say in this presentation, we really wanted to create a meeting place where different types of people could come together to develop a patient-centered ecosystem for discovery and innovation that went all the way from biology to technology to patient care, from initial ideation and investment to druggable targets and deviceable targets, the identification of the same, to clinical trial infrastructure and surrogate endpoints, and into regulation and reimbursement. And we wanted to surround this innovation ecosystem, of course, with equal measures of both equity and access to care. So very similar with, I think, what General Daljit Singh was referring to. You have to come together, whether it's locally, regionally, nationally, internationally. The fun is in getting different types of people to come together, work together towards a common goal. That is, I think, the greatest thing. If we can do that, there is no limit to what we can achieve. So what about patients in the Kidney Health Initiative? So one of the things that we did within the Kidney Health Initiative was right from the start, we had a patient and family partnership council. You can see some of the patients in the top right panel, and the goal of the patients in the Patient and Family Partnership Council was to really keep the patient perspective front and center. And what I'm going to do now over the next few slides is really describe to you one of the projects that we did within the Kidney Health Initiative, which was really to address this lack of innovation in dialysis. But the special part about this project was that it was very, very patient-centered due to the PFPC. And the project was really to say, well, if the current forms of dialysis are inadequate, how do we get to the next step about better forms of renal replacement therapy? And I'll come to access in a moment. But right at the start, when we started off this project, our patients made us realize that we had forgotten something in the dialysis arena that actually the founder of dialysis, Wilhelm Kolff, from the Netherlands, shown on the left, had emphasized 40 years ago, and he had said that if the treatment of chronic uremia cannot fully rehabilitate people, then that treatment is inadequate. Again, I will emphasize that dialysis keeps you alive, and yes, there are problems with access, which I'll come to in a moment, but it doesn't allow you to live. And so with the help of our Patient and Family Partnership Council, we completely decided that whatever comes out of the roadmap, and even right now we don't know what will come out of the roadmap that I'll show you in a moment, it had to improve the patient's quality of life. It had to improve their ability to work and travel. It had to increase their mobility and physical activity. It needed to liberalize their diet and fluid regimen. It needed to reduce their medication burden. It needed to reduce the number of interventions that patients have to undergo. Dialysis patients have to undergo a huge number of interventions. And really, most importantly, we wanted it to reduce financial impact, because do remember, it doesn't matter which country in the world you live in. Chronic diseases always drive people into poverty, and there isn't a chronic disease that does it better than kidney care, unfortunately. So in order to achieve this improved patient quality of life, we identified or decided upon a continuum of future therapies that we wanted to bring up or build up altogether, which went all the way from enhanced dialysis to wearable dialysis, to an implantable kidney, to actually regenerating a kidney. And we have described in detail, and if you put in Kidney Health Initiative roadmap, this will come up. We have described in detail some of the things that need to be done. But the most important part of the roadmap was actually that we spent a lot of time on regulation and reimbursement. And this is another important message at a global level, which is that you can have the best idea, the best biology, the best drug or device, but unless you have a regulation and a reimbursement system that allows the drug to get into practice, it's never going to reach the patients that so desperately need these new therapies. And our hope really was that the roadmap would be a catalyst to enhance innovation in this field, interest in this field, and to generate investment. One of the dreams that we have, and I still have this, is that we wanted the roadmap to encourage small startups with innovative ideas to come into this field. And the example that I like to give is that if you are a small company with a new technology to filter or desalinate water, we hope that the roadmap will bring them into the kidney world to filter blood. I do want to emphasize here, and this has come up a couple of times, and there was a very good comment in terms of what are the things that AFMC should look for in the future, and sort of biodesign had come up yesterday in the conversation. India has great startups. On the right side, you see some examples of the 42 unicorns. So in the startup world, a unicorn is a small startup that ultimately has grown into a $1 billion company. But there are very few Indian startups in medical devices. And I just want to put out, especially to the younger people in the audience, that there's a huge role for physicians here, because you have to ask the right question and you have to identify the right gaps in care. So if you're a young physician with a good idea about changing a device or doing something differently, find out people who, and there are lots of them in India, overseas, who can help you to get that idea into a small company, a startup, and into commercialization. Now, everything that I've spoken about in the context of the roadmap till now has been in the context of a technical roadmap, but I want to emphasize that this roadmap is also a roadmap to freedom for our patients, which will take them from in-center hemodialysis to portable hemodialysis to our hope in the future to an implantable kidney. And again, when we think about freedom, we're only limited by our imagination. So this is a picture of a dialysis patient who unfortunately has now passed away on portable dialysis, rafting down the Grand Canyon. I mean, this sort of thing is possible only for 0.00001% of dialysis patients, but why can it not happen for more? So now I'm going to switch gears a little bit and really ask myself the question, do we actually have the science to do the things that I'm talking about? And I'm going to submit to you that we do. So we actually have a wearable artificial kidney that has gone into initial human trials. There's a group in San Francisco that's working on an implantable bioengineered kidney where the goal is to take silicon nanomembranes for filtration and see if you can coat tubular cells onto the top for the reabsorption. There's lots of work on kidney organoids that are made out of stem cells under the right milieu. And this shows an example from Harvard University, from the Mass General, where they put flow over cells, just normal tissue fluid flow, and that really enhanced the vascularization. And over here, if you're a nephrologist, you can see the outline of the glomerulus made with podocytes and sort of an afferent and efferent arteriole going into it. The other really exciting thing that's out there in terms of kidney replacement therapy is that genetic editing, where you can get rid of the carbohydrate antigens on pig endothelium that used to result in a hyperacute rejection, has actually, has changed the world of xenotransplant. There's a really innovative model that people have started to use that I want to show to you, which is on the right. And the issue for xenotransplants is that you ultimately have to put a pig kidney into a human and you don't know what's going to happen, right? It has to be a human as opposed to just non-human primates. But in order to de-risk this, what people have started doing, which is again very innovative as a model, is that they're taking people who are brainstem dead, not a candidate for for donation, taking off their own kidneys, and then just connecting the pig kidney to the femoral artery and the vein. And these pig kidneys are the gene-edited kidneys without complement and without these carbohydrate antigens, and see how they do. And the results for me have been spectacular. So this is, if you look at the right panel in particular, right bottom left, this is a kidney that's connected to the femoral artery vein of a dead patient at 54 hours. It's not black, it's actually still pink. This is amazing. And in the left lower panel from another group, you can see that you can actually produce urine out up to 4 hours. So I think that this field, after many false starts, is going to change things. But the big question is, all of this relevant in low and middle income countries such as India? So in India, there are 215,000 new patients with end-stage kidney disease every year. But there are only 175,000 patients on dialysis and about 10,000 transplants every year, which means that obviously there are huge numbers of patients that don't get care. The cost of hemodialysis, if you add in everything around it, including physician care, etc., in the private sector is $30,000 a month. And despite programs like Ayushman Bharat and the National Dialysis Program, 50% of all dialysis costs are actually borne by the patients, and particularly, and you know this, I'm just repeating it, and particularly in rural areas, the access to care is obviously very, very, very poor. And I would argue to you that the industrialized model of dialysis in terms of cost and this need for highly purified water in regions of chronic water shortage and relative lack of infrastructure doesn't make sense. And again, if you were to let your imagination run wild, you'd want to have something that's cheap and sturdy and portable, battery operated, that can regenerate the dialysis. So basically run on 3 liters of, not this small bottle, but on 3 liters of bottled water. And I would argue to you that technology can help with this. So the traditional way of regenerating dialysate is shown on the left. It was bulky. You had to run it through different things. But there are ways now to do photooxidation of urea into nitrogen and carbon dioxide by running an external electric field over titanium oxide, and this could potentially fit in a backpack, so you can convert the urea into nitrogen and carbon dioxide. So again, innovation changing things. And there was also a prize competition run by the International Society of Nephrology, which was won by this engineer from Ireland who is not involved at all in kidney care. That's the importance of getting people from outside the field in. And this is a solar-powered device that boils water and makes it pure so that it can be used for peritoneal dialysis, but the steam produced is also used to sterilize the system, and potentially it could also be applied to hemodialysis with tweaks. So that's about innovation in the dialysis world. And I just, again, think about what I've said in the context of your own specialties about how innovation, particularly patient-centered innovation, could change things. Couple more points that I want to make. So obviously, you don't just want to treat kidney failure, you want to prevent the progression of chronic kidney disease. And I will argue that after years of no therapies, we now have a plethora of new therapies. We have the SGLT2 inhibitors, we have the mineralocorticoid receptor antagonists, possibly the GLP-1 agonists. And as a kidney community, we have to seize the moment. Just as in many cases in your specialties, you also have to seize the moment. And this slide just shows you some very nice data about how the SGLT2 inhibitors and the mineralocorticoid receptor antagonists are actually very effective by reducing a composite endpoint of kidney failure and proteinuria and creatinine rise by about 30%. The challenge is how do we get them into the patients who need them? And in the kidney world, we actually have a bad record. So we've had ACE inhibitors and angiotensin receptor blockers now for over 30 years. But as this slide sort of shows you, if you look at the entire population of patients with chronic kidney disease in a large registry, more people were on drugs that are bad for the kidneys, like non-steroidal anti-inflammatory drugs and proton pump inhibitors potentially, as were on ACE inhibitors and ARB. So how do we avoid this thing happening again? And again, in all of your specialties, this obviously happens. And the way to do it, obviously, is through implementation pathways, education and awareness of both physicians and patients, patient advocacy. Very, very importantly, and this is true again for all countries, even whether it's a public or private healthcare system, how do you pay for it, right? So if you're a payer, you want to be able to identify the patients who need these drugs the most. And I think that's even more important in countries like India, because complete and broad access to these new therapies, which are really quite remarkable, could allow patients to stay off dialysis, which is often unaffordable. The big question, of course, is, well, how do you identify these patients? And that's why I'm going to talk a little bit about the Kidney Precision Medicine Project, which is a large initiative in the United States. And the University of North Carolina, where I work, just became one of the sites. And the goal is really to do kidney biopsies on patients with chronic kidney disease, with acute kidney injury, but also collect a lot of information about their clinical presentation and about what happens to them 1 year, 5 years, 10 years down the road. Now, once we get the biopsies, what we want to do is that we really want to use state-of-the-art technology, which is quite amazing. So this is an example of a detailed histological assessment of different cellular phenotypes, and through a system called Codex, we can identify up to 30 different antigens on histology. But it's not only histology that we want to do, we want to then overlay that histology with a single cell molecular imaging of transcriptomics and proteomics and metabolomics. In other words, we want to do spatial transcriptomics, where we would be able to say that this particular cell type in this region of the kidney is actually expressing these sorts of molecules in patients who go on to progress as compared to patients who don't go on to progress. We're also doing advanced imaging with functional MRI, and if you look look over here, I've outlined this in red. You see these differences in blood flow between a control or normal kidney and a patient who has chronic kidney disease. At the end of it, and this is obviously the really exciting part of it, we want to put it all together. So we want to bring in the clinical presentation, the outcomes for that patient, the detailed histology, the spatial transcriptomics or metabolomics, and the functional imaging, put it all together to identify surrogate endpoints for clinical trials. We all want to identify mechanisms that will allow us to identify druggable targets. And most importantly, we want to identify novel biomarkers for risk stratification. Because if we can risk stratify patients in chronic kidney disease early on, and if all of you can risk stratify patients in your fields, then we would be able to use these novel therapies, which are often expensive, in patients who would benefit the most from them, thereby reducing resource utilization and cost. And that's the way that we're going to increase implementation of new therapies. So finally, I'm going to end with some messages for the future. The first is patient-centered innovation, and it could be discovery or process of care innovation, is absolutely essential if we want to address the issues that are important to our patients. It's also the right thing to do. And as I get older, definitely, it becomes more and more obvious that at some time in our life, we are all going to be patients. The second message is that we need to involve patients in innovation, and nothing makes the case as well as this video that was actually made by a patient called Celeste Lee, and I'm just going to play this video with sound.
It's Cece, a fellow kidney disease patient. For 33 years, I've done dialysis, both chemo and PD. I had a transplant for 10 years, and as you can imagine, too many pills, shots, and accesses to mention. As kidney patients, you and I both know that a few things in life are not optional. Strength, courage, persistence, and determination. No matter what life throws at us, we try to stay balanced, maintain our routine, and remain positive. But let's face it, we are often in a holding pattern. Kidney disease treatments have not changed much over the years. The options for patients like us have largely remained the same for many years. You want to help change that? We need you. Each day we're asked to share our lives with our treatment. But now let's share our voice, ideas, opinions from patients like us. They matter. You people are realizing our voices matter too. Here's what I found out. Food and Drug Administration, often known as the FDA, is looking for patients living with kidney disease, like you and me, to provide input on how potential treatments of the future could look. Picture a big table. Around it are dialysis caregivers, researchers, doctors, nurses, and companies providing new products and treatments. They want us and our families to sit beside them and have a seat at this table. We'll work together to bring potential new treatment options, safe and effective ones, and ones that patients like you and me want and need. Imagine the future of your treatment. What does it look like? How does it improve your day-to-day life? This future doesn't have to remain just a dream. Join me and other patients to contribute our thoughts and make our ideas a possible reality. This is my invitation to you. Lend your voice and work with the people who can help make it happen, with one shared goal, living better with kidney disease.
So that video was made by the lady on the left, Celeste Lee, who was a member of our Kidney Health Initiative Patient and Family Partnership Board of Directors. Celeste died about 3 years ago. She chose to stop dialysis really because 25 plus years of dialysis had made her bones so brittle that her sternum had literally collapsed into the heart. And again, I think that really should be a charge of us in nephrology, definitely, but for all of you in your fields to try and address the issues that are important to patients. So the next, so the next message, and there are just 2 more messages after this that I want to share with you is, if you want to go fast, you can go alone. But if you want to go far, you should always go together. In the context of innovative dialysis therapies, we don't just want to build a better dialysis machine. We want to be disruptive. we want to go far. This is an African proverb, though, that is applicable to whatever field you're in. My third message is about innovation as a whole. So yes, you need ideas and resources for innovation, but even more importantly, I think you need passion, you need patience, and you need persistence. And finally, more than anything else, in innovation as in life, you have to believe. You have to believe in your idea. Otherwise, you have to believe in that you're going to be able to change things. Otherwise, you're never really going to be able to change things. And I just want to end by saying that I do believe. I believe that innovation is an important part of the solution for the problems that we face in kidney care in medicine. I believe in AFMC and in the Armed Forces Medical Services. And I also believe, and some of this came out yesterday, that the Armed Forces Medical Services are really unique as an organization that could be ideally suited because of the way that you're structured to implement some of the innovation principles that I described. And again, I know that in the field of organ transplantation, you've really been able to bring everyone together. And I just think that the opportunities to innovate in this environment are actually huge. And so with that, I want to thank you, AFMC, for everything that you have given to me. I want to recognize in particular my fellow R-batchers in the audience, Generals Daljit Singh and General Ashok Jindal. I thank you to the chairpersons, but most of all, thanks to all of you for your attendance. This has truly been an amazing honor and privilege for me. I've given a lot of talks, but this is a particularly special talk. I first came onto, it may have been the same podium 44 years ago when we had the freshers debate, and it's very, very special to stand here again. Thank you all. I'm happy to take questions.
Yeah. Thank you, Dr. Roy Chaudhary. I think that was a fascinating talk, and I am going to permit some questions, though for orations, I'm sure you're willing to take questions, but I just want to emphasize 2 or 3 really impactful things that you said. One is the sheer size of the burden of kidney disease in the world. You said 850 million, close to 1 billion. 1 in 7 global citizens have kidney disease. And the other startling thing you said was that once they go on to dialysis, 50% of them will be dead in 3 years.
Yes, even if you have 4 hours 3 times a week.
So that's what I'm saying. So that's a really important thing. What you also said is the dialysis provides very poor value for end-stage kidney disease. I'm sure that's something new that most of us learned today. Most of us would believe that patients on dialysis have, it's a very good thing going for them, but you're saying it's actually very poor value. And that the 5-year survival on dialysis is lower than most cancers. The other startling thing that you brought out was that there has been practically no technology improvement in dialysis over 60, 70 years, which is pretty startling. You're saying the technology has remained practically constant for a very long period of life. And what you also brought out, which is hugely important in India, is a huge cost of dialysis that kidney patients have to bear, not only in terms of financial costs, but in loss of ability to earn a living and to do a lot of things in life. What I also really liked was what you said, that all innovations that you need to do now should be patient-centric, and it's extremely important to take the patient's view. You starkly brought out the differences in how patients view things and how physicians view things when they're looking at treatment modalities. You brought out more interesting fields, wearable kidneys, xenotransplants using the kidneys of pigs for patients. And towards the end, you brought out the exciting field of precision medicine to put together multiple modalities to identify what individual patients need. And you obviously had specific messages for the future to conclude. So I think all in all, it's been a really fascinating talk. I would now invite the audience to ask Dr. Roy Chaudhary any questions. Dr. Ashok Jindal is whom we'll start with.
Ravi, lovely talk. I know you're a die-hard optimist. I mean, as you rightly said, that transplant in India has not taken off greatly because of various reasons. and dialysis patients don't have a high quality of life. Are there some timelines, innovations wherein we could look at an artificial kidney in the near future? For a developing country like ours, it's very important.
Yeah. I actually, so very important question. And it's wonderful to get a question from you, Ashok. Uh, I think that the changes in gene editing, right, which is it's a powerful technology that can allow you to adapt these big kidneys. I think it means that xenotransplant may actually end up becoming a reality before an artificial, totally implantable kidney. But I think, and I will try my best, I think that in about 5 years, there may be some 5 to 7 years, there may be some version of an artificial kidney that is really small and portable, maybe about so big. That now it may be outside the body, so more like a wearable thing. But I think that will come in about 7 years or so. I thought you were going to ask me the question about prevention, which I couldn't put in as much into my presentation because of time. And I will say that you can use innovation very aggressively in education, in awareness, and for the prevention of kidney disease. And a lot of it is that people don't know that they have kidney disease. So, getting the word out through social media, for example, in the right way, I had a picture of Prime Minister Modi on a Twitter feed when he had mentioned about the importance of organ donation, using point of care devices to measure protein in the urine or to measure your creatinine, using innovative ways to educate people digitally potentially, but in their own community, using cell phones to get the word out. Those are all ways that innovation can actually be used for prevention, which I would say is, in a way, the most important.
So I really enjoyed your talk. I'm Brigadier Sameer Kumar. I'm head of the cardiothoracic surgery department. I have a special interest in organ transplant. I have a comment, sir, and a question. We all know the Achilles heel of all organ transplants is chronic rejection, and that is because in the last 4 decades, the immunosuppression hasn't changed. You are still with calcineurin inhibitors, antimetabolites, and steroids. All organs eventually get rejected. Why? Because there is no effort on to improve the quality of immunosuppression. The newer drugs which are coming in are the Zumabs, and the newer therapies are not affordable and are not available. So what is your comment on that, sir? Why does an industry work around xenotransplant? Yes, but again, you'll have problems of organ rejection. So I think the Achilles heel is the to kind of prolong the organ life by having better modalities of immunosuppression. That's my comment, sir.
Yeah.
Thank you so much.
So again, a very good comment, and I'm going to jump on that to sort of again make the case of the things that we could do. So one of the things obviously is increasing deceased donor donation. So increasing kidney donor donation. That's particularly relevant for India. It's relevant everywhere. And I was actually just at a meeting in Dublin before I came here about trying to think about new ways that one could take kidneys from older people potentially, right, but actually rejuvenate those kidneys and then use them. So that would, in a way, increase the number of kidneys. And